Okay, for those of you who are using the pre-printed notes, here's what the first thing says. For any real number b with a fractional exponent b to the 1/n is the same as the nth root of b. So the denominator determines the index, except when b is less than 0 and n is even. So we'll get into what happens there. So if you're not sure what that means, let me show you the examples, and I think that'll help. So if we have a to the 1/6, that's really the same as the 6th root of a. And you have to be able to switch back and forth between these two forms in order to do these problems, okay? And you'll see what I mean. And, oh, that was a. And then b is w to the 1/2, which can be rewritten the square root of w, which really can be just written like this, okay? So for number 2, let's go the other way. Let's say we have the 5th root of b, so that's the same as b to the 1/5. Again, you have to be able to flip back and forth depending on what we need to do. And the other one, the square root of w, is w to the 1/2. Okay, so we have to be able to go back and forth. Now, for those of you, again, who are using the pre-printed notes, it says b to the m over, that should be m over n. Let me change that to m over n, is going to equal the nth root of b to the m, fill in that blank, I missed that, or you could do it this way. Either way is correct, okay? And again, you'll see, except when b is less than 0 and n is even, then we're talking about imaginary numbers, okay? And we'll do that in a minute. So let's do a couple of these problems. What does this look like if we're actually doing a problem? So a is 49 to the negative 1/2. Well, the first thing you need to remember is that a negative exponent, we talked about this, and you guys got to remember that means that everything has to go to the bottom. So this would be 1 over 49 to the 1/2. Okay? That's how you fix a negative exponent. You either move it from the numerator to the denominator or the denominator to the numerator. This actually means the square root of 49. Well, the square root of 49 is 7, so our final answer is 1/7. Okay? Oh, this is number 3, A and B. And then B, 32 to the 2/5. Well, there's a couple ways you could write this. Our index is 5. 32 is what's in the radical. Now, we could put the square inside or outside. I'm going to put it outside, and here's why. We're going to do the 5th root of 32. Well, 32 is 2 times 2 times 2 times 2 times 2. And then we're going to square the results of that. So look what can come out. 2. And then we square that answer and get 4. Depending on the problem, depends on where you want to put that exponent, either in the numerator. So notice, the numerator of your fraction becomes your exponent. The denominator is your index on your radical. Okay, so that's where they went. Okay, here's the bullet points in order to know that you've simplified all the way. Use the properties of powers, the rules of exponents. Leave the exponents in rational form. All positive exponents. That's still a rule. That's always been a rule. If it's a negative, you better move it to the other floor. Any exponents in the denominator must be a positive integer. Which means we cannot have fractional exponents in the denominator. That's the same as having a root in the denominator. Your answer should be in rational exponents if the problem is in rational exponents. So if we start out with a fractional exponent, our answer should be in fractional exponent, okay? So your answer should be in rational exponents if the problem is given in rational exponents. So if you start out with a fractional exponent, don't end with a radical. Okay? So there's some of the rules. All right, so this is really just manipulating back and forth. So here we go. Let's try some of these. Number 4 is y to the 1/7, y to the 4/7. Now here's where a lot of issues come if you don't know your rules. The first thing is to know your rules of exponents. If you have like bases and you're multiplying, you add exponents. Okay, well that's great. We can do that. Now you have to know your rules of fractions. If we're adding fractions, they have to have a common denominator. The common denominator is 7, and so the answer is 5/7. We leave it as 5/7, u to the 5/7, and we don't make it a radical because our problem started with fractions in the exponents. Okay? Number 5, x to the negative 2/3. You should immediately know there's a problem here. The problem is that negative. That cannot stay. So really this is 1 over x to the 2/3. The next thing you need to see this is we cannot have a fractional exponent in the denominator because that's really a radical. So we need this to be x to the first power. Well, I have x to the 2/3 power. How many more thirds do we need to make this 3/3? Well, we need another 1/3. But again, the rules of algebra are whatever you do to the bottom, you have to do the top. The numerator and the denominator are the same. So again, we're multiplying by a big fancy 1 here, so it's not changing the value. So now I have x to the 1/3 in the numerator, and in the denominator we really, again, have x to the 2/3 plus 1/3 because we add like exponents, or like, when they have like bases, we add the exponents, and really that's just x because it's 3/3. Okay, and so that's my final answer. There's nothing I can do. You cannot simplify a 1/3 and an x because that's really the third root of x. We don't know what that means. Okay, now let's go to number 6. This is the 6th root of 16 over the third root of 2. Now, because this problem started out with radicals, your answer should be in radical form. But we might have to flip around a little bit. So let's change this to 16 to the 1/6, and in the bottom we have 2 to the 1/3. Now this is where you just have to start learning these. That 16 can be written as an exponent, which is 2 to the 4th. 2 to the 4th is 16. I'm going to leave the denominator alone for a minute. We're just going to deal with the numerator. Here again, what do? A power to a power. Well, a power to a power, we multiply. 4 times 1/6 is 4/6 because there's a 1 under that 4. Top times top, bottom times bottom. In the numerator, we have 2 to the 3rd, 1/3. Well, look what happens here. Simplify that 4/6 just like you would any fraction. What are the rules if we're dividing like bases? What do we do with exponents? So you can see exponents and fractions come into play here. We subtract them. So it's 2/3 minus 1/3. When we subtract fractions, common denominator, and only subtract the numerator. In this case, 2 minus 1 is 1. We keep the denominator as 1/3. Now the problem started out in radical form, so it needs to end in radical form. So we need to convert it back to a radical. Okay? So whatever we start out with, that's where we need to end. Okay, number 7. We have the 6th root of 4x to the 4th. Well, the first thing I know in the end I have to go back to radicals, but I want to see what I can simplify here. Well, there's no jailbreaks that can occur, so let's rewrite this and see what happens. And sometimes this is just messing around with it. Okay? All right, let's do this. Let's write 4 as 2 squared. I'm just changing things around. Now I can do powers to a power, so really this is 2 squared to the 1/6 times x to the 4th to the 1/6, because it's the whole thing raised to the 1/6. Okay? Now what happens? Well, 2 squared is really 2 over 1. Power to a power we multiply, so that's going to be 2 to the 2/6. And the x is going to be x to the 4/6. Now you have to simplify if it can be simplified. So 2 is really 2 to the 1/3, and x is to the 2/3. Okay, well, what do they both have in common? They have a 3, so that's my radical, that's my index. 2 is to the first, so we just write that, x squared. Why did I go back to radical form? I went back to radical form because that's what the problem started with. All right, number 8 is pretty tough. We have y to the 1/2 plus 1 over y to the 1/2 minus 1. See this? And some of you might need to do this. If this gets a little confusing, you might need to do this. This really means this. And so this goes back to the last lesson. We need a conjugate. Remember, the conjugate is the same number. The same number is written, but the opposite sign in between. And whatever we do to the top, we do to the bottom. And then we're going to FOIL. Okay? So this is going to be the square root of y times y plus 1 root y plus 1 root y plus, plus 1. Because I did this times this, then I did this times that, 1 times root y and 1 times 1. That's where I got what I got. On the bottom here, I'm going to get root y times y. Then I'm going to get plus 1 root y minus root y and then minus 1. Again, if we did this correctly, the middle term should cancel out, which they do. And this should free up our radical, which it does. It's y. So this is y to the 1. Now we're not finished with the numerator. Let's finish up the numerator here. Well, this would be a y. This would be 2 root y. And this would be a 1. So our final answer is y plus 2 root y plus 1. Ugly, I know. Over y minus 1. There's your final answer. Okay, we're almost done this. I know, this is tough stuff. This is not easy. This takes practice. So if you decide not to do the homework, you're really going to struggle on this. Okay, so an expression is simplified when it has no negative exponents. You know you're done when this happens. No negative exponents. It has no fractional exponents in the denominator. And the index is as small as possible. So we've simplified as much as possible. All right, let's do that number 9 together. This is like the mega problem for today. We have 2x to the 1/8 over x to the negative 16th times x to the 1/4. The first thing I need to do is figure out what's going on the bottom here. So I need to combine like terms. Well, they have like bases, so that means we can add the exponents. I'm going to leave the numerator alone for a minute. But if we're going to do that, We have fractions, so they have to have a common denominator, so I need to fix it. So I need to both of them have 16 as the denominator, so this should be 4/16. Well, what is negative 1/16 and 4/16? That's 3/16. Okay? So far, are you with me? Now here's the problem. I need to make sure there's no fractional exponents. So I really need in the denominator, I need x to be to the first power. Well, I have 3/16. How many more 16ths do I need to make x to the first power? I need 13 more. Whatever I do to the denominator, I do to the numerator. So now this is what I have. I have 2x to the 1/8 times x to the 13/16. Now what do I have on the bottom? I have x to the 16/16, right? Because 3/16 and 13/16 is x to the 16. So that's good. We're really just having x here. Now in the numerator, we want to add those exponents, so we need a common denominator. So we have 1/8 plus 13/16. Our common denominator here is going to be 16. So if I put a 16 here, that means 2/16 is the same as 1/8. 13/16 is in the numerator. In the denominator, we're still with an x. So now we have 2x to the 15/16 over x. We do not change it to a radical because the original problem had fractional exponents, so our answer can stay as fractional exponents. We'll spend a lot of time going over the homework.